Hello, everyone, and welcome to Derivatives of Exponential and Logarithmic Functions. This is the first two-part series. It's really too long to do in a single video, so we're going to break it up. This is part one. So there's actually no notes on this first page. These are just properties that if you have forgotten them from pre-calculus, then you need to know them. They say that if you have log of u times v, you can break it up into addition. U divided by v can be broken down into subtraction. And recall that if you have an n as an exponent there, you can bring that to the front. You're going to need to know these. And also don't forget that if you have a base a and you raise it to a power with a log base a, they cancel each other out and you just end up with x. Same is true if you have a log base a of an exponential thing with base a, then again, it's just going to cancel right out. Likewise, e to the ln of x is x, and ln of e to the x is equal to x. If you are in honors, you should put all of these things on your appendix. If you are in AP, have fun making sure you've memorized them all. Okay, so this first section has zero calculus in it. It's all review. So I'm going to quick write down the answers for you, and you can stop the video and see if you can do them all on your own. And then just go back and listen to the ones that you actually need help with. Oops, 2x minus natural log of 5. So you can take a screenshot of that, check your answers as you go, but I will work them all out now. So this is to remind you that an ln and an e is the same as a log base e of e squared. Whenever you have a base of a log and a base of an exponent, they cancel each other out and you just get 2. So same thing here. A natural log and an e just cancel each other out and you get -1. Now this one doesn't have a power. So your first step would be rewrite it as a power, and now you have an ln and an e, and they cancel each other out. Likewise, e, if that's the base, and the power is an ln, that also cancels each other out. If you're thinking, this is so easy, it is going to get harder. It's just to remind you. Even if it has a complicated expression, e to the ln of x squared plus 1, it's just going to be x squared plus 1. If you have ln of e to the sine of x, I hope you're feeling confident now, like you've definitely got this. ln and e cancel each other out, just like squares and square roots do. But now we have a dilemma. Your first step is going to be to use the property that says if you have a log of u over v, you can change it to log of u minus log of v. In this case, natural log, but the rule still applies. So only this one simplifies. The ln and the e cancel each other out, but nothing's going to cancel out that ln of 5, so that's going to stay. Similarly, you can't separate this e and this, there's a plus sign there, so you can't just cancel that and make it 2. So you're going to have to use the laws together. But I can make it e to the ln of 2, oh, catch this, times e to the 3 ln of x. Because when you multiply like bases, x squared times x to the 3rd, what do you do with them? You add the exponents. So likewise, if the exponents are being added, you can break it back down into a multiplication problem. So the first one does become a 2, but you can't cancel an e and an ln if it's got that 3 in front. But what you can do is you can change that ln, 3 ln of x to ln of x to the 3rd. Again, a lot of properties from pre-calculus all having to come back to you now. So that 3 moves to the exponent, and now you just have an e and an ln. Now they do cancel each other out. and you get that. Likewise, I can change this to e to the 2x over e to the ln of x, because subtraction, just like if you had x to the 5th over x to the 3rd, you would subtract them because they're division, x to the 5 minus 3. So where did this e to the 2x minus ln of x come from? It must have come from this. And the top cannot be simplified. It doesn't have an e and an ln, which are inverse functions. It just has an e. But this one does. E and ln are inverses, so they undo each other. Hopefully this is coming back to you. Now, this is still review. On these 3 problems, this is to remind you that to solve for y, you can exponentiate both sides. So e to the ln of y is equal to e to the x squared. Remember that? We exponentiate both sides, because if you have a to the x is equal to a to the y, then x must be equal to y. So I'm actually putting the a in there. I'm making it e to the ln of y is equal to e to the x squared. That allows me to get y by itself. And we have e to the x squared. Sometimes I'll see people put that 2 out in front. That is only true for logs, those rules. Not true for this one. I will quick write the other 2 answers up in case you'd like to try it on your own, which is always a good thing. And then I'll do the problems out. And y is equal to 1 over 1 minus e to the 3x. Okay, number 11. So if you have an e that you're trying to undo, now instead of exponentiating both sides, I'm going to take the natural log of both sides. Make sure you don't take the natural log of individual terms. Rather, you have to take the natural log of the entire side. That cancels this. So I get 3y is equal to ln of 2 plus cosine of x. And then I divide by 3. ln of 2 plus cosine of x. The entire thing divided by 3. You'll notice when I wrote the answer over there, I put the 1/3. That's because sometimes people do this wrong. 1/3 feels a little safer, but it is an or. There's nothing wrong with divided by 3, unless, of course, you try to actually divide by 3, which you can't. Okay, for this last one, the property that you need to remember here is that natural log, well, actually what I really want to say first, that's why I started to erase, is that I want to put a warning in. Do not e individual terms. If you tried this on your own and you got the wrong answer, you cannot e individual terms. So don't go e. Bad. Okay? Don't do that. You can only exponentiate both sides. Think about it. If you have x is equal to y, then e to the x must be equal to e to the y. The exponents have to be the same. But if you have a plus x is equal to y, you definitely cannot be sure that this is going to be true. Okay, so don't do that. So how do we condense these first? That's the key word. So condense first. And we do that by doing natural log of y minus 1 over y is equal to 3x. I've condensed using those properties. Now I can e both sides. E to the natural, I guess I'll rewrite it. E, a lot of times I just add the e, which is probably what you're going to do. E to the ln of y minus 1. Sorry, that did not want to write. Of y minus 1 over y is equal to e to the 3x. So I can do it to both sides, but not individual terms. On this side, I'm left with y minus 1 over y is equal to e to the 3x. Now, interestingly, as big a deal as I made about that, this is still not done. This is still a really hard problem. So first step is always to clear your fractions. Multiply both sides by y, and that gives me y minus 1 is equal to e to the 3xy. Now I'm going to get all the y terms on the same side. Remember, we did this with implicit differentiation, and then we factored out the y. Is this coming back to you? Whenever you have more than one variable that you're trying to get all by itself, put it on the same side and factor it out. 1 over 1 minus e to the 3x. And that's the answer. We still haven't done any calculus yet today. We're about to. But all of these skills are things that you're really going to need to have. People in AP, I cannot stress how much natural log is on the AP exam. People in honors, if you would like extra practice on this, I have a worksheet that you can have. Okay, but this is pre-calc. All right, let's move on to the calculus. Introducing the best function ever for taking the derivative. Okay, the constant function is pretty great. The derivative of a constant is 0. But e to the x is a pretty close second. The derivative of e to the x is e to the x. It's that easy. Unless it has something other than x. Then the derivative of e to the u, meaning something other than just plain old x, is still e to the u, but then times the derivative of the inside, so to speak. So for example, on number 1, you're always going to just rewrite it. The derivative of e to the u is e to the u times the derivative of u with respect to x. So the derivative of sine is cosine. Of course, some people might choose to write it out in front, but that really didn't make anything better. Okay. All right, so again, you are welcome to try these on your own. I will quick write the answers on the side because I think some of you could probably do some of these. And then I will do them out for you. And 5. Okay, let's do them one at a time. So the derivative of e to the u, so here's my u. The derivative of e to the u is e to the u. You never change it. It should always look the same. Times the derivative of u, which in this case is just 1. So y prime is just e to the x plus 1. Cosine of e to the x, so I've switched it up. I'm not taking the derivative of e right now. I'm taking the derivative of cosine. So you hopefully remember the derivative of cosine is negative sine of the exact same thing. You never change the angle. So the derivative of cosine of e to the x is negative sine of e to the x. But then times the derivative of the inside. So times the derivative of e to the x. And what's the derivative of e to the x? E to the x. And I just realized you can't, I don't know if I didn't write it or what, but there should be a negative there. You could write it as negative e to the x sine. The only reason you would do this is if you thought you were accidentally going to write sine of e to the 2x or e to the x squared or something like that. You could put it out in front to make sure you don't accidentally combine the two e's. Next one, the derivative of sine is always cosine of the exact same thing. Actually, don't need the parentheses, sorry. Cosine of e to the negative x times the derivative of this. So my u, I'm going to do it off to the side, is e to the negative x. Derivative of sine is cosine of u, same exact thing. And now I'm going to go over here and I'm going to do the derivative. And the reason I went off to the side is because some people get this wrong. The derivative of e to the negative x is e to the negative x times negative 1. Because the derivative of e to the u is e to the u times the derivative of u. So there's a derivative of the inside within a derivative of the inside. So it helps to do it off to the side there. Minus e to the negative x. This one definitely would normally be written negative e to the negative x cosine of e to the negative x. They would put it out in front. If you forget these parentheses, it'll mean subtraction and it'll definitely be wrong. Last one. The derivative of e to the anything is e to that exact same thing. It never, ever changes. Times the derivative of u. So this is our u. So the derivative of e to the u is e to the u times 1 plus 2x. So hopefully you liked it. The two hardest ones were not the ones with the e. It was really the ones with the trig. The three that were just e to the something, very straightforward. You just repeat the thing, and then you do the derivative of the exponent. All right, again, I'm going to write some answers real quick here off to the side in case you're kind of like, I'm getting it. I think I can do it. That would be great. Ooh, this answer is a little long. Okay, let's do these out. So there's two ways to do number 6. One way is to use product rule. Do not just take the derivative of the first one and the derivative of the second one and multiply them together. That would be wrong. Or you could simplify first. You know, I'm a big fan of that. Simplify first. Almost as big a fan as factoring. So I'm going to simplify it. I'm going to write it as e. When you have two like bases, you add their exponents. And now it's an easy problem. This is my u, right? So e, the derivative of e to the u is e to the u times the derivative of u, which is 2x minus 1. That's my answer. So there's also two ways to do the next one. You could do product rule twice, because see, there's a little product and there's a little product. And when you got this product, you'd have to remember to distribute the negative. Or you can factor out to simplify it. That's what I would do. So that's how I'm going to do it. If you do it the other way, you'd have to use the product rule twice. So y is equal to, look at me, factor out the e to the x, and then I have x squared minus x. Now you might be thinking, oh, you could have factored out the x also, Mrs. Shaffer, but if you factored out the x also, then you'd have 3 different things being multiplied, and we only know a product rule for 2 things being multiplied. So I do want to factor out, but only into 2 pieces. So that's why I chose to take out the e to the x. So now I only have to use the product rule once. So y prime is the second times the derivative of the first. I love this. The derivative of e to the x is just e to the x. Plus the first times the derivative of the second. So I'm just going to factor out that e to the x from both of them. So or I guess, did they multiply it out? I think they multiplied it out just to get that answer. There's lots of ways to do it. Actually, I am going to factor it out because I want you to see how that's done. So there's two pieces here. If I take the e to the x out of the first piece, I'm left with x squared minus x. If I take the e to the x out of the second piece, I'm left with 2x minus 1. And then I can simplify that to e to the x times x squared plus x minus 1. So let's say that's how you did it. And you look at the answer and you're like, oh, that's not what I got. Isn't it? They just distributed the e. E to the x times x squared plus e to the x times x minus 1 times e to the x. Okay? In calculus, there's so many answers. You really have to kind of look to see if yours is the same as another one. Okay, so same answer. You guys can write it either way you want. But you can't stop here. That's not considered simplified. Okay, you should simplify it. Okay, number 8, basic product rule. Whenever you have two things, please do not take the derivative of one at a time and then just multiply them. So the second times the derivative of the first plus the first times the derivative of the second. So the derivative of e to the negative 2x is always the identical thing times the derivative of the u. So it's e to the u times the derivative of u. Memorize that formula or write it on your appendix. So now I'm going to factor out. So I have two pieces, and I see that they both have an e to the negative 2x. They both have a 2. When I take those things out, I'm left with a 1 here, because I took everything out, but there's still a 1 there. So that's the first one. And on this one, I took out the e to the negative 2x. I took out the 2, but not the negative. So I'm left with negative 1 times, and I didn't take this out at all, 1 plus 2x. So I'm just going to rewrite the 2 out in front. And then this is 1. Now I'm going to distribute this. Minus 1 minus 2x. And this actually simplifies quite a bit because this whole thing just becomes minus 2x. And so my final answer is negative 4x e to the negative 2x. That's where they got that from. Where was the calculus? Step 1, product rule, derivative of e. Where was the algebra? All the rest of it. Okay, lots of algebra in calculus. So the point of number 9 is to make you understand that if they tell you something's a constant, how does that affect things? So people look at this and they think quotient rule because they see a fraction, but it's only quotient rule if there's a variable on the bottom, not just an a squared, which is a constant. So the first thing that I would do is I would take the 1 over a squared out. And then I have ax minus 1 times e to the ax and kind of put them on the same plane, as it were. So this is like this. That way I can have the numerator times the numerator, and I just took that denominator out because it really doesn't matter. So I take that denominator out, and now what am I going to do? Product rule. You're going to get so sick of product rule. But hopefully I'll say it enough that you won't forget to use it. So the second times the derivative of the first. If this was 2x minus 1, you would just write 2. So I'm just going to write a. Plus the first times the derivative of the second. And it's a little complicated, so I'm going to write it over here. I'm going to call it m. E to the ax. M prime is still e to the ax, but times the derivative of the u. So I get e to the ax times a. All right, I've got this on the outside, and I have two pieces here. What do they have in common? Well, I can take an a out. See, they both have an a. I can take the e to the ax out, and that should leave me two pieces. If you start with 2 and you factor out, you still have 2 left. What did I leave here? Nothing. I took out the a and I took out the e to the ax. So what's left? Hopefully you said 1, not just nothing. And on this one, I took out the a and the e to the ax, so I'm left with ax minus 1. I don't need the parentheses anymore because it's not being multiplied by anything. I know you're looking at your own piece of paper saying, I don't have unlimited space like you do. No, I love this board. I can just keep scrolling down. Don't worry, when you're a parent someday and your kids grow up, they're going to have something more like this, and you're going to say, back in the day. All right, so this just becomes ax. So now I can actually multiply. Straight across the top is a squared x e to the ax. And straight across the bottom, all of these are just over 1. It's just a squared. So these cancel, and I get that. That's my derivative. You're doing a great job. All right, the derivative, so this one's almost the same. The derivative of a to the u. So in other words, the rule that we just learned was very specific. We learned that if y is e to the u, then y prime was e to the u du. But e is a very special beast. A is just any constant that's greater than 0. So for this one, if you have 9 to the negative x, you literally just have to write down this formula. Or if you're an AP, memorize this formula. So it's exactly the same. Just like e, you're just going to rewrite it. And just like e, you're going to put a du dx. So what's the derivative? This is my u. What's the derivative of that? -1. Here's the little extra thing. The extra thing is that you have to add natural log of 9. That's the extra thing. How come we didn't do that for e? We actually did. You just couldn't see it. What's the natural log of e? It's just 1. So it didn't matter. But technically it was part of the formula. We just don't need to write it. Can you write this better? Not really. I mean, I guess I could stick that out in front. I don't know. This isn't really going to improve no matter how you do it. Okay, let's try another one. So I have an a, meaning a constant that is part of an exponent. So the derivative is always going to be the exact same thing. Don't try and take the derivative of any part of it yet. So I just did it. A to the u. This is my u. I rewrote it. Times the natural log of a, the natural log of 3, times the du dx. So now I need the derivative of u. So if u is cotangent of x, do you remember the derivative? You have to memorize it if you're in AP. You should have it written on your appendix if you are in honors. Cosecant squared x. You know, I'm just going to box it right here. This really doesn't get any prettier no matter how I rearrange it. I feel like I'm missing. Oh, the derivative is negative. So I'll say or. I guess you could stick that negative out in front. But I'm not really sure it helped you very much. But I don't want you to forget it. Okay. So these are going to keep coming up, these little tangent lines and slopes, just over and over again. I'm going to keep scattering them throughout the problems to make sure that this is something you remember. At what point on the graph of the function y is equal to 2 to the t minus 3 does the tangent line have a slope of 21? So I don't know if you remember what basic exponential functions look like, but e to the x looks like this. You're going to want to know that. As another aside, if you're making an appendix or if you're memorizing, this is e to the negative x. Two graphs that you really need to have either in your appendix or memorized. And the same is general shape for a to the x or a to the negative x. This is the general shape. But ours, they cross at 1. 0, 1. So ours has been moved down 3. So if it normally crosses at 1, I'm going to move it down 1, 2, 3. So it's going to go like this. That means its asymptote, which is normally at 0, is going to be there. So it's 2 to the t minus 3. At what point does the tangent line have a slope of 21? 21 is pretty steep. So slope is 21. So the question really is, when is y prime equal to 21? That's the question. So y prime is, so the derivative of 2 to the t is just 2 to the t times the natural log of 2 times the derivative of our u, which is just 1. So y prime is 2 to the t natural log of 2. When is that equal to 21? This is the equation we need to solve. So my first step is I'm going to divide both sides by the natural log of 2. And does anybody remember, this is one thing we did not review at the beginning of the hour, does anybody remember how to get rid of this? I know if it was e to the t is equal to something, I know you would take the ln of both sides. Ln of 21. Do you know how to get rid of a base 2? There was the clue. Do you know how to get rid of a base 2? So the reason this works is because ln is really log base e. You're taking log base e of both sides. So to get rid of this, you want to take log base 2 of both sides. So log base 2 of something with a base 2 cancels out, and you get this horrible, messy thing, which if you typed it into your calculator would be approximately 4.921. All right, so I know we've already worked pretty hard on this problem, but we're actually not quite done. It does say at what point on the graph. Point means you do need the x-coordinate and the y-coordinate. So we have found the x-coordinate, 4.921. Now I'm going to tell you what the temptation is. The temptation is to take that and plug that into the y equation. But this is a rounded answer, so you can't do that. So instead, we're going to have to plug in the original, which I will show you how to do on your calculator in just a minute really easily, but it's actually not that hard by hand. Y is going to be 2 to the log base 2 of 21 over ln of 2 minus 3, which when you have a log base 2 and an exponent base 2, they actually cancel each other out. So it's 21 over ln of 2 minus 3, which if you plug that into your calculator will be 27.297, which is not the same if you plugged in 4.921. So I'm actually going to go back up to this step because this last little bit here, this is the calculus. You understood that you should take the derivative and set it equal to 21. The rest of this is just some hard algebra. So while I would love for you to be able to do hard algebra, you can do this on your calculator by setting this as y1 and this is y2. So I'm going to do that for you now. So I want to take just a minute and show you how you could solve this equation without actually doing all that algebra that we just did. Always want to be bringing you back to this concept that if you have the equation 2 to the x, natural log of 2, is equal to 21, you can put both halves of the equation as your y1 and your y2, and then just graph it and see where it intersects. So I hit graph, and I see my first graph, and I don't see the second graph. Why? Because it's y is equal to 21. So even though kids like this method, there is a little bit of work involved, and that is you do have to get the window right. So you have to go, so for your window, you do have to go and make your y max enough that you can see it. And we might even have to change x too. Let's see if we can see it. We can, okay? So now I do second, calculate. I want to know where they intersect. When there's only two graphs, you can go pretty fast. First curve, enter. Second curve, enter. Guess, I never guess. And it'll find it for me. So notice that it says 4.921. All right, second really cool feature. Your calculator has gotten the exact value, not the rounded value, the exact value. So now it'll remember that that's what x is. So I can go back to my original equation, because remember I need to find the y value, and I can say 2 to the x, and it'll remember what you just found, minus 3. And it'll give you the exact answer, which is 27.296. If you had rounded and said 2 to the 4.921 minus 3, it's not the same answer. And you might be thinking, it's pretty close. It is pretty close. If you're an AP, you don't get credit for that answer. It has to be correct to the nearest thousandth, and this is not. If you're in honors, you still have to do it this way, because I want to know that you don't just round answers, that you can get the exact answer so easily using your calculator. All right, and that ends part 1 of derivatives of exponential and logarithmic functions. Have a great day.